All right. So, where are we? I haven't been in this building in a while. This is building 50. Who are you guys? What are we talking about?
I'm Oren Rosenbloom. I'm the development manager for the Windows Portable Devices team.
Okay.
We built in Windows Vista and Windows Media Player 10 and 11 support for all devices, media player devices, like your MP3 player. And in Vista, we also are supporting cameras and cell phones, and built a platform so that other developers can go and have fun with these cool devices.
Cool.
Yeah, I'm Vlad Sadovsky. I've been dealing with the various toys and devices for about dozen of years. And latest, I'm an architect. I'm trying to make it easier for developers to talk to different toys connected to Windows, which have been bumpy road.
Very interesting. So let's talk a little bit about that. So you're providing sort of a framework for any type of device that Windows supports. There's a driver for.
Right. So yeah, we built an API at the very top level, and that's what developers write to, and that's what many Windows experiences write against and have implemented against. We also supply a set of what we call class drivers, which are actually user mode drivers, or just DLLs. Those are good because if something goes wrong, then it doesn't blue screen the machine.
Yay.
And so those user mode drivers, we have a few of them. As I said, they're class drivers that just enable a wide range of devices. So they're not specific to a particular vendor. They're specific to a particular type of device. So most place for sure media player devices today in the market use our built-in class drivers. So you just plug in the device, get it right out of the box, plug it in, just works without having to install any software. We have the same for cameras. We're working on some for cell phones as well. A good example of another class driver that we have in the system is for Microsoft smartphones and pocket PCs.
Okay. Excellent.
Right. I would add there too that we have this. We have been evolving for a while, starting from the silos, as typically it's done. We did when we did the cameras, then branched into the music players, and we realized that we're not going to do all the devices. It's too wide and impossible to tackle with a huge thing. We decided to go two ways. We decided three ways actually. We decided to serve developer community, to give them access to connectable portable devices. That was seemed to be was not existing at the time. We decided to serve users by having a built-in experience in Windows to have the cameras and phones connecting to PC just like a keyboard. You don't think. Now, back 18 years ago, you would think before connecting keyboard. You have to install code, find the code and stuff. Now you don't think, connect. And then finally we decided it was our goal as a customer front-end team to drive basic Windows infrastructure forward, like creating new driver models and stuff so that we can benefit from them, but also improve Windows as a connective tissue between software developers and hardware developers, which is its role.
Excellent. Which is really what an operating system is, right?
It's one of the greatest functions of the operating system, especially important in the mass market world where we're heading with Windows.
Fantastic. So let's for a moment talk a little bit about the developer story here, because there's a lot of developers that watch Channel 9 videos and stuff. So when you say class driver, you're talking about a driver that supports a class of device. Yes. So it's a generic driver.
Right.
And as a developer, I can write just one chunk of code that I could then drive, not necessarily drive, but interact with various types of devices, right?
Right. So that's an excellent question, actually. So all these different types of devices out in the marketplace, they speak a different language over the wire. And in fact, we also have some wireless support. We have support for Wi-Fi cameras. You speak to these devices in a different way. They each speak a different language. Not all of them speak English. And as an application writer, as a developer that wants to just interact with these really cool devices, do some interesting things with them, I shouldn't care about that. It shouldn't matter to me how I speak to this device, and that particular camera, I need to send this command before I can do that command, and this MP3 player is different than that one. Who cares? They're storage devices. They play back music, or they take pictures, and I want to get those photos off, or I want to push some interesting music on, or I want to take contacts off my phone so I can synchronize, that sort of thing. That's what I want to do as a developer. So what we did is we built this API. It kind of abstracts all the differences between these devices and allows you to communicate with them as a software writer in a common way. So they all act the same as far as I'm concerned, but they speak a different language under the covers.
Right. Now, speaking about developers, we also, developers were our, as any platform, is a primary target. Yeah, we serve users, we serve hardware developers, but essentially it's people interact with the system through the software. So then we will look, you asked about developers, we also looked at how can we build a platform without being tied too much to a particular device class. Like, it's not just a camera, it's not just a music player. Like, what is the key pattern? And that's what we decide to look at. What is developer pattern? And the most common pattern we identified with this portable device is that it's a intelligent storage paradigm. You deal with a piece of plastic which holds the data, whatever it is. And when you connect to a computer, your application wants to either move data around or control the device or get events from a device. That's how the thinking about platform went. Crystallize the pattern, crystallize the needs of a developer, then build it. And an example of this is that after we started evangelizing the platform, device classes started connecting to it, which we never thought about, like medical device which you carry in your pocket, which given to you by hospital to measure some data. When you bring back to computer, you want to see data in Excel. Why not? Did we envision it? Not quite. Is it possible to build it in? Yes, and that's an indication, in my opinion, is what is a good platform. It's a forward compatible for a developer.
Excellent. And so, in that case, how would a developer be able to interact with a device where there's no drivers on the system? I understand what you're saying about you created these generic class drivers, but
so that's very interesting too, and that's where it helps that we've been doing this for a number of years. We went through the pain. What does it mean to a user or to developer not to rely on the presence of a piece of code? And that's where we realize that you have to understand that where the particular device class is in its evolution. If device already is mature and really in a business-wise shipping device plays in some other role, like in the cameras, for example, it serves a role of either printing or online service or other things. Then it's for a vendor of a device, Canon, Nikon, and others. It's actually important to give healthy platform to software developers without worrying about driver. Then they rely on us and other partners to get in the standards bodies, to create the public standards, which we did with the cameras and phones. And then we write the code, we write the driver as a part of the platform. So we complement our APIs with the built-in driver. In other cases, specifically namely phones, where vendors are not ready yet to commoditize, Nokia and Sony Ericsson stuff, they differ by their PC story. In this case, we have our platform is open-ended. Then we can say, okay, well, you want to have your device exposed to software vendors? Yes, develop a driver package. We'll help you distribute it through Windows Update, or you will ship it together with the device, or you will ship it on a CD. But yes, it will be not a smooth experience. It will have to be a step of installing driver, like it traditionally is.
Right. That's a typical Windows model.
yeah, very interesting. I've been doing a lot of interviews with the driver people.
Yeah.
I mean, they're innovating as well, as you guys know them all.
Yes.
User mode driver framework,
Exactly.
kernel mode driver framework, et cetera, et cetera.
Right.
So it's very interesting because if I know as a developer that there's a generic class driver already on the system for me for a camera, I could just write code to do whiz-bang interesting things on top of that and not have to worry about crashing the system.
Exactly.
So very cool.
Right, so actually you mentioned the user mode driver frameworks.
Yeah.
The Windows Portable Device Platform is actually built on top of the user mode driver framework. So
All right.
you build a standardized user mode driver, and with some specialized commands that you support, you are now an official Windows Portable Device driver.
Very cool.
Right.
So you want to look at some code or play around with some stuff? Or?
Yeah, so
Right.
let's fire up some demos. We're going to be playing with a pre-release version of Windows Vista, so whatever happens, happens.
Hey, let's see.
Yeah,
It's pretty rocking.
Toys are there to play.
Cool. Gonna move this guy around. Okay.
All right, so what we're looking at here is actually this is a Creative Zen Vision M
Nice.
portable media player device. It's actually quite nice. Has a very nice large screen. You can view videos on this. You can view photos, and of course you can listen to music. This is a place for sure device. It just plugs into Windows and it just works. It works natively with Windows Media Player, and it also plugs natively into the Windows Shell experience. And I have both of these up. And so what you can see over here is I call this Oren's Zen Vision M, so I get to fully customize this, and Windows views this as, okay, that's my vision, so if you have one, then we plug it in and you can name it whatever you want as well.
Cool.
And I can double click into this, and I now start drilling down. And what it shows me here is I have storage media, which is what I expect, which is about a 30 gig drive on that. An interesting point here, and I'll bring up another device in a few minutes, and it'll make the point, but when I double-clicked on that icon, if you notice, it was actually a customized icon. So it looked similar to this device. That icon comes off of that device automatically, because we don't install any software when we plug this in, so we still need to get some information from it. So the icon ships on the device, and this device, if not this one in particular, but other devices can have multiple storages in them. So you might have some built-in storage, or you might have some, in addition to that, you might have a card reader for a flash card, like an SD card.
Yeah.
So drilling in gets you into this storage media, and then you double-click there, and in a few seconds we get some folders coming up. And these are just the folders that exist on my Zen Vision M. I can drill down into music as an example, and I have a bunch of songs here. I'm going to pull up another folder, and I'm going to just transfer a few songs over to my Vision. So what I'm doing now is I'm just copying a bunch of files over to bunch of music files, they're actually WMAs, over to the Zen Vision M, which is kind of what you'd expect when you have a device that kind of acts like a storage device.
Absolutely.
So, that's cool. This isn't actually a storage device. It speaks some different language over the wire. But you can do some extra interesting things that you couldn't do with a regular storage device. I'll show you what I mean. So if I select these, now these are files that are on this device right now.
Okay.
And multiple selected, then I right-click, I can create a playlist. It says creating playlist on the device. Take a couple of seconds. I'm just going to name this. Let's call it Oren's Playlist. So what I did now is I just told the device, hey, I like these songs. Maybe I'm going to listen to them at the gym. I want to create a playlist so when I take this device on the road with me, I can go and listen to my playlist. And so there's some interesting things you can do with that playlist. You can pop up the properties page, and if I look at this tab, it actually shows me a bunch of these files that are part of my playlist, and I can move these up and down to decide what order I want them in, that sort of thing. That's pretty much it.
That's cool.
Now, similarly, I have Windows Media Player over here. It too shows this creative Zen Vision M. Shows it as my device. Shows the custom icon over there, and I can drag and drop a bunch of files. Let's scroll down a bit. And I can say, you know what, I actually want to start synchronizing. And let's see. Oh, looks like these are already on the device. So, let's do something more interesting. Okay, I'm just going to wing this. Let's transfer these same files out. The media player doesn't want to add them to the list. In any case, this is how you would synchronize music to this device. You have the start sync, and all of these are already on the device. I can delete them, and we can sync to them, but that's less interesting.
Yeah.
What is interesting is if I unplug this device. It's going to take a few seconds to finish updating. I can drill down into that music library, and if I go down to that playlist, there's that Oren's playlist that I created. And if I drill down into that, it'll show me those 4 songs that I had there.
Yeah, very interesting. And the important point to make, of course, because we are speaking to developers audience, the common APIs, the value of the common API is here, that all these functions which Oren described are accessible in a uniform fashion, independent of the form factor of a device. In fact, that already speaks to the point I was making earlier. You think about pattern. The design pattern is storage, active storage. It's storage which can be commanded and controlled. And it's in Windows what we did, we actually extended the paradigm of basically a floppy disk, which was also storage, into being smart. This device was the first example of device can work independent of a PC. It comes with a PC, it becomes companion. And in your code, whatever Visual Basic or C or whatever code you write, you can uniformly take advantage of all of this and perform all these functions, progressing from floppy functionality into smart storage design pattern.
Excellent. So, I mean, the question that arises is the operating system on the Zen, because it is an operating system.
That's right.
Has a different file system than
Different
what Windows.
file system.
Everything.
It doesn't have any form of Windows on it.
No.
That's exactly true.
Yeah.
And that is the value that the Windows Portable Device Platform brings to Windows and to developers, in that you can have pretty much any operating system, any firmware running on your device, as long as you speak a language that either Windows has a built-in class driver for, or a driver exists for it. You can just start communicating with that device.
Excellent.
And another important point here too is that speaking about it, not only we don't worry about what is the OS and what is the hardware on the device, we also don't worry at the point of designing code which exactly functions it has. And that's what one of the key points of WPD had been, how do we deal with multifunction devices as a software object?
Good
right?
point.
Which has always been a trouble. If you use print scan fax, which is how we started being exposed to the multifunctions, it's always slightly inconsistent, right? You print or fax or something, then you say cancel. What do you cancel exactly? From your code, you call cancel. So WPD is our attempt to iterate on the OS infrastructure for a device based on common design patterns, common platform for software developers, and no assumptions made about particular configuration, trying to be agile.
Excellent.
Right. Let me pop up another device up there and
Sure,
we
let's
can
do it.
demonstrate some of what Vlad was just saying.
Okay.
So here I have a different device. This is a camera. Some would recognize it as a Canon Digital ELPH. I'm going to turn it on. There we go. This out of the way. And I'll shrink this down. Say no to that. So what you might notice right here is we have an autoplay dialog that pops up, and it knows, hey, this is actually a camera. And a lot of people who've experienced autoplay in perhaps Windows XP, when they plugged in their camera, frequently they would see this searching for files dialog that would last, say, a few seconds or even a minute or so. And what's happening there is it's actually trying to determine, what files are on this device. Let me find what predominant type, and usually on a camera it'll find they're mostly JPEGs, and then it'll say, oh, this probably is a camera. Let me allow you to import pictures. I'll give you that as an option. This popped up actually instantly. It didn't search for files or anything else, and the reason is this camera is intelligent enough to say, you know what, I actually support pictures. There may not actually be any photos on the device right now, but I can take pictures and you can import them when I do have pictures on there. So it communicates that to Windows through the portable device platform, and it gives you these options where you can import pictures and you can browse files. What I'm going to do here is I'm going to again open the device view of this, and if you notice, this is kind of similar to what we saw before, but now we have two different types of storages. One is fixed, which the camera is choosing to report, which actually isn't all that interesting, although if you want to upgrade firmware, you can take advantage of that fixed storage. And then there's removable storage, which is actually the SD card that's in this device. If I drill down into it, I actually have a picture there, and I can, let's say this, I can drag that over, and I can double click on that photo. It actually happens to be a picture I took a couple of days ago. So that's interesting. That's what you'd expect from a camera.
Yeah.
But here's a photo that's actually on my desktop. I'm going to drag it to my camera.
Wow.
It's not something you usually tend to do with a camera.
No, it isn't.
But a lot of people actually forget that cameras have a really nice screen on them. So if I unplug this, I now have that photo that I transferred over to my camera. So now I have this ability to use my camera as a photo album that I take to my friends and kind of show them the pictures on.
Excellent. So portable device.
Exactly.
Like a media player.
Exactly.
Cool. And then if you continue even further, then you realize what is being enabled by this. Is that now you can actually build the code without worrying about particular protocol or data or driver or whatever. You can just focus on a user. What user wants to do? Carry stuff with them. Try to use the stuff. Whatever the stuff is, digital bits, objects, properties. You can write corporate application, right? But actually, realistically, you can now easily whip up the code for Oracle database to get the pictures and maybe even music clips from an insurance agent's device, which they carry with them, or phone, which until now would been, yes, it was possible, but then somebody has to build the code specific to Canon cameras, and Oracle would have to talk to them, and developers would be having massive headache with all these different permutations and APIs and stuff. That was it's designed to do. It's designed, okay, you have all these portable devices which are multifunction in nature, can help workflows of different types. You can integrate them in applications being a consumer or line of business. And it should be, you write code once, and then yes, of course you test with some devices, but the more devices are generic and standardized, and the more agile and flexible platform is, the less is the need is to change this connective tissue which we are building. And eventually it's enabling developers to do some other cool stuff. Maybe using this device as a social network exchange container. Yes, there is internet and there is peer-to-peer networking, of course, but there are limitations to direct connectivity. And this is designed to complement them.
Absolutely. Well, I mean, one example that came to mind was I have a cell phone.
Yeah.
I have pictures on my laptop or my computer, but I'm not connected to the internet, and I want to send a picture to a friend.
Exactly.
I just do what you just did.
Yep,
That's right.
Absolutely.
That's really cool.
Yeah, exactly right. So our vision was that, okay, yes, we address specific customer scenarios because that's the only reasonable way to build a platform, but the platform is designed in a flexible way to have a future cool stuff to be created on top of it.
So cool. Let me show you one more thing.
Let's do it.
Still have some time. Actually, what we have over here is a device that most people won't recognize as an actual device. This is a blood glucose meter.
Huh.
You know, nothing interesting about this. Diabetics know all about this because this is how they measure their blood glucose levels. It's actually connected to Windows through the portable device platform. This is not something that ships with Windows. It's a prototype that we built in-house just to kind of validate and prove the point that you can connect pretty much any type of device.
Okay.
This device, in fact, is a serial-based device. It's not USB. And what I'm going to show you here is, hey, this appears in the Windows shell.
Nice.
And when I double
Interesting
click on
icon that it has.
Yeah, it's just kind of a generic icon.
I just kidding.
Yeah.
I mean, you can't automatically generate icons?
Actually,
that'd be cool.
Actually, yes, it's a very interesting question too, because again, if you think about users prefer to have experience personalized and customized. So actually, jokes aside, we did build facilities for a developer of the host software to interrogate device for visuals. If device can supply visuals, your experience gets customized.
Excellent.
If it doesn't have, we have a backup.
Sweet. All right.
So again, we have the same experience. You double click and I go to internal memory. And what's interesting here is, let me go to this detail view. It represents readings that are on this device as files. You know, maybe that's not very useful, but it kind of demonstrates the ability of the platform. And I'm going to show you one more thing, which is near and dear to every developer's heart, is what cool tools do you have to help me really build my platform and my software. So just right here, really quick, this is kind of just an example showing a reading with a timestamp on it. Just, okay, you know, proves that this is an actual platform.
Well, and it's really interesting given the class of device that this is.
Yeah, exactly.
It's very impressive.
Right. Yeah, we've been talking media devices, but we're not media at all, actually. We're kind of generic. So I'm going to pop up this other tool called WPD Info, which is a very generic tool and really gives you a view of what's going on behind the scenes. As you'll know, it might be hard to see, but it popped up this dialog that says One Touch Ultra, which represents this blood glucose meter device. And if I click OK on it, it's actually going to show me the hierarchy of this device. So let's just shrink this down. At the top level, at the root, it's a hierarchical display. At the root, I have something called device, which represents the device itself. And everything beneath it would represent an object, some sort of object on the device. In this case, it's a storage object. The way I know that is, well, I actually know it because of its unique name, but if you look at this property, which is a WPD functional object category, it actually has a value of functional category storage. So you can programmatically go and ask the device, what type of functional categories do you have? In this case, it says, I have this one storage. Other devices, such as the Zen Vision, will actually have another functional category that has nothing to do with storage. It's actually called the rendering information category. And what that tells Windows is, hey, these are the types of media I can support, I can play back, and these are the various bit rates in which I can get them back in and other interesting data about that media. So if I drill down into this object, it actually shows me the same thing we saw in the Windows shell. Each of these numbers represents a file that we saw in the shell before. And each of these properties represents that one object and describes that one object. So, for example, here we have some customized property that says, it gives you a number of 132, which actually is a unit of milligrams per deciliter, which is actually the unit of measure for blood glucose.
Excellent.
And okay, so I won't drill down too much into
But it's still
this
pretty
tool.
amazing that you figure that out from a generic
You can.
old
Exactly.
device.
It also puts you, like, if you think about, again, what is fundamental shift is happening is that consumers and developers are starting to look beyond form factor into services and functions device can provide to you. So it's really the same paradigm shift is happening with the move to services all around the software, right? You think about function, what is useful, how to represent it. You start thinking much less about what particular protocol it talks to, what the form factor is. Is it just a camera? No, it may be multifunction. I interrogate it dynamically, I use it in my application, and I rely on function and a service, not on the form factor. That's what I think is shift is happening, and we're trying to be at the forefront of it.
Excellent.
Let me show you one more tool. This is the last tool, I promise.
No, that's fine. Tools are good.
And what I did in the background while Vlad was speaking is I plugged in that camera again, and I launched this application called the WPD Monitor tool. Now, what's very interesting about this tool is it actually gives you a look into what's actually happening in the stack. I'll scroll down to something interesting for some of you, and it's a real-time look. So, scroll down, and I'll start. You might notice there's some transactions. Like here, for example, I asked the device to get me its device information. And, this is very cryptic, but this actually starts explaining to you, perhaps in English, the type of commands that this device can support. And someone who understands the platform, after reading our excellent MSDN documentation, will actually be able to really interpret this, and it's an amazing tool for debugging. In fact, this is one of the primary tools we use for debugging the platform in Windows Vista before we ship it.
Excellent. Really
so
cool.
if you scroll down, and I'll kind of give you a feel for the real-time nature of it, it tends to be quite verbose. I just, again, started drilling down into my device, and in real time, it's showing me what's happening at every layer of the stack, including what Windows is sending over the USB wire to the device and how it's responding.
Wow.
So it kind of stopped. You might notice that there's some interesting operations like enumeration find next. So clearly it kind of makes sense. We were trying to browse into the files on the device. We needed to enumerate the directories and files there. So we sent some enumeration commands to the device. This has been an amazing tool for working with Windows, building applications. Our internal and external partners use it. It's available today online in Microsoft, off of Microsoft.com, even before we released Vista. So it's really a tool that I recommend people to use when they start playing with the portable device platform.
Now, it brings up an interesting question. Does the portable device platform require Vista?
Excellent question. No, it doesn't.
Okay.
I guess we're kind of done with demos. So the portable device platform came out in its infancy in Windows Media Player 10. By that I mean we shipped class drivers. So Place for Sure devices work with Windows Media Player 10. In the upcoming Windows Media Player 11, which is going to be released sometime similar to the Vista release schedule, that whole platform is available on Windows XP as well.
Okay. Excellent.
So the same API, the same user mode driver frameworks, the same class drivers are all available.
Right.
Very
We
cool.
also realized that, and that's probably important to mention too. It's a chicken and egg problem. Whenever you deal with a two-sided platform where you have software developers and underneath resource managers, which in this case are devices, which one do you expose first? Software developers don't want to write to API until it's supported. Hardware developers don't want to plug in drivers until there is critical mass of software. So, and we decided to provide a platform looking at it holistically, end to end. We assisted hardware vendors with the reference platform for free, basically, giving them not only specifications. We gave them the code to build in their embedded devices to support minimal of our platform. And then we also built in UI components and the examples and APIs to ship down level what we call in previous OSs, specifically to address the need of developers to service their existing customer base. Vista at some point, will hopefully very soon, will be adopted. Until then, software developers need to serve their customers. So that what we give to them. We give them this package. And then Vista adds their more value. So yes, working on Vista will be better.
Sure.
And so Vlad touched on an interesting point that we didn't bring up yet. Windows Portable Devices as an API is a new API. And there aren't very many applications except for the ones in Vista that actually write directly to that API. And we encourage people to use it because it's an excellent API, well designed. But we recognize that there are existing APIs out there that we, Microsoft, put out there in previous releases. Two that come to mind: the Windows Image Acquisition API, WIA, which was used for scanners and cameras. It still exists in Windows Vista. And there's the Windows Media Device Manager API, which is WMDM, which applications use to speak to media players prior to Vista. What we did is we built compatibility layers that enable applications that speak those APIs to speak indirectly to WPD. So those applications don't need to change and don't change. In fact, Adobe Photoshop is a good example of an application that uses the WIA API and will continue to do so in Windows Vista when Vista ships, and will be able to speak to cameras through the WPD infrastructure via that compatibility layer. Lots of investment went into that to make sure that it's fully compatible, so it isn't just a partial compat story, it's full compatibility.
Excellent.
And I would add just one important point to illustrate. One of the most common feedback I've heard is a simple scenario of camera phone not being able to move pictures to computer, where you edit them and mail and stuff, which you just mentioned, Charles. We're not really stupid to demand Adobe to move, of course, all their software right now to the new API just because Microsoft came up with it. What we did with this compatibility layer, the litmus test, is that unchanged Twain and AA applications will be able to move pictures from any device which can hold pictures, as long as they comply, from a phone specifically. So you should be able to connect smartphone or some Nokia phones to Vista and then open up Photoshop or Jask or whatever else is using them and move images. There will be a benefit for them to use multifunction API when they're ready to do it, if they ever want to exercise phone-specific functions. What we set up to do is to have a curve or ramp up for developers to move to the new value we are adding without disrupting their existing applications or creating too much of an expense to the bulk of new code.
Right, so that actually ties into the stepped API model that we've decided to build. Because as Vlad was saying, you don't want an application to go and wholesale have to all or nothing adopt your new API or not. They've invested in an older API, which we think is great because it was new once. But we have this new, more functional API that we are releasing. We enable them to continue using that old one and gradually begin using the new one without having to abandon the previous investments. So, for example, the WIA API doesn't allow you to transfer photos to a device like I showed you in the demo. It allows you to acquire them from the camera, but you can't send them to the camera. So what you can do as an application developer is you can continue to acquire your photos using WIA, and if you want to add some new functionality that allows you to send photos or write photos to the camera, you can use WPD at the same time, and they don't conflict with one another.
Excellent. Very cool. And so what's your community presence like for this stuff? Like, what are you guys doing? Do you have a blog? Do you have, the big blog thing here at Microsoft?
Not yet, actually. Okay. So it's something that we definitely realized we need to start up. We've been focusing on getting Vista ready to ship.
Of course.
And right now what we're doing is we're ramping up our community efforts. This is the first step.
This is the first step.
Yeah.
And we have a wiki on Channel 9. We have we have forums, stuff like that.
Cool.
So it's all open.
Excellent.
But are there any other specific areas of this you want to address? I mean, basically, so what I've heard so far is that you're treating external devices as just storage systems.
Smart
right?
storage. Yeah.
Smart storage systems. But let me ask you this though. What is it about a phone that, say, isn't running Windows, right? And
Right.
phones that run Windows certainly are cool,
Right.
but most people don't have them yet.
Sure. Yep.
And there's always going to be heterogeneity out there for good reason.
Yep.
So how do I deal with that? You need standards. You need some sort of.
Okay. Let me take this one. So you're heading. That's a big topic. You can be asking multiple questions. One of the questions would be, how do we provide for smooth user experience in our applications which we develop when the devices are all heterogeneous and different, right? And that's, as I said, it's a multi-step, multi-phase story. How do we get there? While preserving the needs of hardware vendors to differentiate which they want, while giving the software developers the ability to exercise functions which are value add to different devices, like in vertical scenarios, right? So the way you do and the way we approach it, we go and first we create this layered set of abstractions, architecture. That's what we do, and the key here is to have it mapped over years, right? So in this case we decide, okay, well, we have this vertical stacks for different phones. Nokia has one, Sony Ericsson has one, Motorola had one, smartphone phone had one. We decided to create one split in the middle to exercise one function, which is intelligent storage, object storage plus commands and control. The next step would be, in order to provide driverless story, we would need to have to work with an industry to create a common standards. Even this would not be enough. Why? Litmus test. Exchange context files between two different phones. And there is good likelihood they will not understand each other. So after we create the platform to move stuff around in a consistent fashion, we will then need to work across the industries to schematize or create the common schemas for most common data types. Now, the internet industry already started doing this, so you see it's much more advanced with the software, with the XML-based standards and stuff like this. Devices are a little bit behind. We are hoping that by breaking this silo model first on the connectivity, we'll start this journey toward enabling true interoperable data exchange, workflow. Not just data, but also commands. And furthermore, actually, in order to be trustworthy, because you should realize, what is the characteristic of this device we're talking about? It's portable, it's self-powered, and it has stored bits. Because it's portable, it means it can be lost, which means that we also have to assist sensitive data to be protected somewhere. Do we do it now? No, because we couldn't even talk to the device until Vista. Now we can talk to the device, now we can start adding value by standardizing some things, extending other things so developers can add value, and then creating a new value by having algorithms to protect, integrating with the file systems and things like this.
And actually, to touch on what you just said a little bit on the security point, we started, of course, in Vista making inroads into the security arena. True also for portable devices. One of the things that we added, which system administrators, IT administrators all over the world have been begging for, is a way to secure their desktop. These devices are portable, they have tons of storage. I can walk into a company and walk away with a lot of their confidential data that they don't really want me walking out the door with. We have group policies in Vista today that allow you to deny write access to these devices. So you still want your employees to be able to enjoy their music in the office and perhaps even share some documents, like view documents on their device, but you don't want them walking away with documents from your company, so you can't transfer files to that device. So we give you that flexibility. Of course, it's just the first step. There's a lot more that we plan on enabling in the future, but that's definitely a distinguishing feature between Windows Vista and Windows XP.
Excellent.
Which is actually also reinforces answer to your question. Yes, what is this third-party phones we don't have Windows inside would benefit from? Well, they will benefit from this variety of software using it and ability to plug in the different frameworks which we give to them. Because if you go say to do group policies, what do you need to do? You need to build an agent in OS talking to the backend, which is Active Directory or System Management Server, which has to then control operation of different devices. If you have n stacks, you basically have to replicate your agent n times. And furthermore, if new vendors, say like I know some new phone company comes up next year, creates their new phone, a new stack, bingo, we just lost all of our value for this phone. We have to rebuild it. So that's why we decided to start this whole journey with splitting the stack where there is a common ways to talk to the device.
Excellent. So let's talk a little bit about what's your, you pretty much already touched on the grand vision here.
Right.
So I can't really ask that explicitly since it's already been answered. But so let's talk a little bit about the future. Where is this heading? Like, in broad strokes, not product
Yeah, sure.
promises.
There's about 1 billion different directions it can head in, some of which we are trying to, I guess, make sure they do head in that direction successfully. The first is breadth, right? You want to make sure that more and more devices can connect into this platform. The more devices, the more device categories you have running under this platform, the more powerful the platform becomes, because you can then unify all the things that we've been talking about under that one platform without having to rewrite your software. Then so that's the device side. Then there's the application space. There are all sorts of very interesting applications that you can write over that, so we're looking into those as well. I know Vlad is gonna bring this up, but I'll throw it out there right away. There's the whole concept of secure storage, where I want to section off a part of storage on my device so that it's protected with some sort of rights management.
Excellent.
We need to go into that direction as well. There's the whole health and fitness space. There are all sorts of very interesting devices that are coming out that can measure your heart rate, and you combine that with maybe GPS type devices. You now have an interesting device where you can measure your performance in your workout. Let's say you go for a jog, you're running around the block. The heart rate monitor sees how well you're running, and the GPS monitors where you're going. You plug that back into your computer, and you can now plot that on a map and overlay it on a real-time map. So there are all sorts of very interesting scenarios that get unlocked once you can free your data off your device.
Excellent.
Right. Yeah, what I would add there too is, you have grand vision, right? You think about what is happening the last 10 years with what users want. Users want to remove basically seams and barriers for using their stuff. They want to concentrate on a task at hand and get the results, not worrying about what geeks worry about, drivers and details and overclocked processor in a new motherboard and stuff like this. Now we are talking about mass users. What also users want, they want to be mobile. Fundamentally, they want to be mobile. They want to move between things and yet keep their data, not worrying about formats, not worrying about applications and stuff. Get the things done. And that shows you where we need to go, what we need to unlock. Okay, we're only unlocking right now with WPD is how PC can talk to these devices. Where users want to go, mobility, well, web. How do we connect to web? How do we make it so that combination of a computer and a device and a web, this triangle, work very well? How do we make it so that users can actually be even more happy with all these gadgets and toys they have? One example, you buy phone, new phone. What is the first thing you usually want to do? Move your address book.
Exactly.
Can you do that now? Not quite. Phones are incompatible. Some business interests are making it even more difficult if you think about telcos and IHVs. But the reality is that people at least want to basically migrate the thing because they want to use a new phone. Can you use computer for that? Yes, you can now, because you can talk to them if there is a drive. So yeah, there's a lot of obstacles to overcome, but if you just think about what's possible if you remove barriers on the path information flow and make it manageable and trustworthy, going through the device or collection of devices you have, collection of computers you have, and your web presence. Tying this all together, that's what the grand vision is.
That's awesome. Now, to add into the other grand vision of the company from a developer's perspective, making software more composable, making it easier to write predictable software, modular software, the whole .NET revolution. Do you guys support writing managed code to do all of this stuff?
Yes. So it's not going to ship built into Windows Vista. Windows Vista is going to have the WPD API, which is a COM-based API. It's unmanaged. Currently in the works, there's a managed wrapper that's being built above that API, and that will likely be released over the web as a downloadable component.
Cool.
Yeah, but that's definitely within our vision.
Excellent. Well, hey, this is really great stuff, and it'll be interesting to see how it evolves over time.
And we hear you, Charles, will be having more online presence.
Yes.
Our objective was ship Vista, enable developers, partners we work with first, and now we are branching out.
Great. Well, as I said, welcome to Channel 9.
Excellent. Thank you very much.
Thank you very much, and thanks all the developers.
That's fun.